To disappear from one place and reappear in another instantly. For generations, teleportation has been the pinnacle of science fiction. But researchers at Delft University of Technology in the Netherlands managed to achieve the first teleportation in history through a real quantum network. But before you pack your bags to teleport around, hold on a second, okay? Today we're going to understand what's real, what's still far off, and why teleporting human biological matter can be pretty complicated. Besides that, we'll see that researchers are studying engines capable of bending space-time itself. Companies are already turning Earth's orbit into future factories to make things up there in space. And engineers are working to recreate here on Earth the same energy that powers our sun. And besides that, people are even thinking about terraforming Mars, you know? Let's try to understand all of this. Hello, Amazing Reality. I'm Amazing Reality, and you're watching Amazing Reality. For a long time now, teleportation has been one of humanity's greatest dreams, at least in science fiction, right? The idea of instantly disappearing from one place and reappearing in another seemed like something reserved for movies. But science has already accomplished something that, at first glance, really seems impossible. Researchers at Delft University of Technology in the Netherlands managed to perform a real form of teleportation through a functional quantum network. But there's a very important detail here, okay? No one was teleported. Actually, what crossed the network wasn't matter, but information. And to understand why this discovery is getting so much attention, we need to leave behind the logic of movies and TV shows and dive into the strange world of quantum mechanics. In the experiment, the scientists used diamonds cooled to temperatures close to minus 270 degrees Celsius. Within this network, there were 3 points called Alice, Bob, and Charlie. The goal was to make the quantum information disappear in one place and reappear in another, without physically traveling the path between them. The secret lies in a phenomenon known as quantum entanglement. When two particles become entangled, they start to share a common quantum state, even if they are separated by great distances. It was precisely this phenomenon that Albert Einstein described as a spooky action at a distance. In the most recent experiment, Bob acted as an intermediary, thus creating a quantum connection between Alice and Charlie. Then, when the information was processed at Charlie, its original state ceased to exist there and appeared at Alice. And it's important to point out that nothing physical traveled between the points, okay? What was transferred was only the quantum state of the information. But then an inevitable question arises. If we can already teleport information, why can't we teleport human beings? The answer lies in physics itself. There is a rule called the no-cloning theorem, which states that it is impossible to perfectly copy a quantum state without destroying the original. In other words, to teleport a person, it would be necessary to completely disassemble every atom in their body in order to reconstruct them somewhere else. And that's where we encounter a monumental problem. The human body contains approximately 7 octillion atoms. Recording the position, energy, and quantum state of each one would generate such an absurd amount of data that it surpasses any currently imaginable computational capacity, at least for now. But there's an even deeper dilemma in all of this, you know? Even if this technology were actually possible, who would appear on the other side? Would it really be you? Or just a perfect copy with all your memories, believing itself to be the original person? This question remains one of the biggest debates among physicists, neuroscientists, and philosophers. Despite that, researchers are extremely excited. The goal was never to create a human teleportation machine. The real goal of these guys is to build the future quantum internet, a network where information can be transmitted with security levels that are practically impossible to breach. In addition, this technology can connect quantum computers that are spread across the planet, thus creating a processing system much more powerful than anything that exists today. In the end, my friends, science fiction imagined machines capable of moving bodies through space, but reality ended up taking a different path, freeing information from traditional physical limitations. And maybe, yes, this is the first stage of a technological revolution that we are only just beginning to understand. For example, a warp drive for us to travel through deep space. That would be interesting, right? Let's take a look at what they're already trying to create. In the history of humanity, the stars have always been an impossible destination. They've always been there, shining in the sky, but separated from us by such absurd distances that even the fastest probes we've ever built would take tens of thousands of years to reach them. For example, when we hear about warp drives, the immediate reaction is usually to associate them with the idea of science fiction. After all, the concepts we've seen in Star Trek, like teleportation and warp drives, seem to belong to the realm of imagination. But there is a group of scientists trying to turn those ideas into a legitimate field of scientific research. The name of this organization is Limitless Space Institute, or simply LSE. Founded by physicist Harold S. White, a former NASA researcher, alongside astronaut Brian Cayley, the institute was born with a bold mission: to fund and accelerate research capable of taking humanity beyond the solar system within this century. Instead of focusing only on bigger rockets or more efficient engines, they decided to investigate something much more radical: ways to travel without traversing space in the traditional way. And the reason is simple. Even with the most advanced rockets we're building today, we'll still be stuck with the same basic principle that's been used since the space age. They burn fuel and push the spacecraft forward. The problem is that interstellar distances are so vast that this method simply doesn't scale. The closest star to Earth, Proxima Centauri, is more than 4 light-years away. For a conventional spacecraft, this journey would easily exceed the lifespan of countless human civilizations. And then comes the barrier that seems insurmountable: the speed of light. According to Einstein's relativity, nothing that has mass can accelerate beyond this limit. For a long time, this seemed to put an end to any discussion about fast interstellar travel. But relativity itself hides a fascinating loophole. The concept of space warp doesn't try to accelerate the ship beyond the speed of light. Instead, it tries to manipulate space-time itself. The idea was theoretically proposed by the physicist Michael Cumbier in the 1990s. In his mathematical model, a spacecraft would remain stationary inside a kind of bubble. The space in front of it would be compressed, while the space behind it would be expanded. Since it wouldn't be the spacecraft moving through the universe, but the universe itself being shifted around it, the traditional speed limitations would no longer be an obstacle. It is exactly on this frontier of theoretical physics that Sonny White and the researchers associated with LSI have focused their efforts. The goal was never and is not to build a warp drive tomorrow or anytime soon, but rather to understand the equations that allow something like this to exist in our real world. The biggest challenge continues to be negative energy or exotic matter. Current models suggest that a warp bubble would require forms of energy that we still don't know how to produce, store, or even control. Or in some cases, we don't even know if they can really exist in sufficient quantities outside of extremely limited quantum phenomena. Even so, scientists argue that investigating these possibilities is not a waste of time. Many of the technologies that seem common to us today were born exactly from research that at the time seemed impossible. Satellites, quantum computers, and even space exploration itself were once considered unattainable dreams for humanity. And maybe that's the most interesting part of this story. The true value of this research isn't just about reaching another star. It's about expanding the limits of what we believe is possible. Because if one day we truly learn to manipulate space-time, we won't just be building a new engine, a new technology. We will be redefining humanity's very relationship with the universe. And since we don't have a functional warp drive yet, we use current technology instead. Let's see what's happening here. When the conventional solid fuel engine is ignited, there's no turning back. It keeps burning until all the available propellant is consumed. No pause button, no shutdown, no second chance, my friends. And this simplicity has made solid fuel motors one of the most reliable technologies in space exploration, but also one of the least flexible. Now, American researchers believe they have found a way to break this historical limitation. The breakthrough was born from a collaboration between the Aerospace Corporation, the University of Southern California, and the United States Naval Postgraduate School. The goal was to create something that many engineers considered practically impossible: a solid fuel engine capable of being turned on, off, and restarted on command during a mission. The solution came from a fascinating modern physics field: plasma. Instead of controlling combustion using valves, pumps, or complex mechanical systems, the researchers developed a method based on extremely fast electrical pulses. These pulses last less than 100 nanoseconds, a tiny fraction of a second, and create small plasma discharges that are able to directly influence the chemical reaction of the fuel. In practice, the plasma works like an electronic switch for combustion. When the pulses are applied, the reaction is stimulated. When they stop, the combustion can be interrupted. It's an elegant approach because it uses very little electrical energy and practically doesn't add any mechanical complexity to the system. But the secret isn't just in the electronics. The fuel used also represents an important innovation. Led by the scientist Alejandro Briceño, the team developed a propellant based on ionic liquid polymers. This material combines traits that are usually hard to achieve in one substance: thermal stability, mechanical strength, and the ability to respond to electrochemical stimuli. The result is fuel capable of remaining stable for long periods in the space environment, withstanding extreme temperature variations without losing its properties. In addition, the system does not require complex pressurized tanks, reducing weight, cost, and operational risks. The implications of this technology are enormous. Small satellites, especially CubeSats, often suffer from propulsion limitations which restrict their maneuvering capability. A restartable solid motor would allow for orbit corrections, avoiding space debris collisions, carrying out long-duration missions, and even exploring more complex trajectories in deep space without relying on expensive and delicate systems. It's one of those advances that may seem subtle at first glance, but can profoundly change the way we design spacecraft in the coming decades. And speaking of rockets, what comes to mind these days? SpaceX, right? So let's take a look at this. Instead of just transporting equipment to orbit, SpaceX wants to turn space into a gigantic industrial park. Regulatory documents now show the company is already taking an important step in that direction. The Federal Aviation Administration has approved re-entry tests for a new capsule called Starfall. Although SpaceX keeps most of the details under wraps, records show that the vehicle was designed for a specific mission: to manufacture products in space and then bring them back to Earth. The tests already authorized foresee the launch of the capsules aboard Falcon 9 rockets as well as Starship. After completing their missions in orbit, the vehicles will return to the Pacific Ocean to be recovered by SpaceX vessels. The documents reveal some interesting features. The capsule is about 3 meters in diameter, weighs just over 2 tons, and was designed to return with approximately 1 ton of payload. During descent, it uses attitude control thrusters for orientation, as well as a heat shield to withstand the heat of atmospheric re-entry and a multiple parachute system to reduce speed before splashdown. But the most interesting thing isn't the capsule itself, it's what it can carry. In orbit, the absence of gravity creates conditions that are impossible to reproduce here on Earth. For example, certain crystals grow with greater purity. Optical fibers can have superior properties, and extremely delicate chemical processes can occur without the interference caused by gravity. Scientists have long explored how to utilize this unique environment. The problem has always been the cost. Starfall seems to have been created precisely to solve this issue. Instead of treating space manufacturing as an isolated scientific experiment, SpaceX intends to turn it into a commercial service. The idea is to offer transportation, time in orbit for automated industrial processes, and safe return of the finished cargo. This is even more important given the future of international space expansion. With the aging of the ISS and the transition to private commercial platforms, companies have already started competing to see who will control the next generation of orbital infrastructure. And the Starfall project reveals something bigger than just a simple re-entry capsule. It shows that the next space race might not just be about more powerful rockets or farther missions. The real competition might be for control over the future factories that will operate above our heads. And meanwhile, down here, the power of the sun is being recreated, my friends. Let's understand this. Nuclear fusion was considered the technology that was always 30 years away. The time for this technology to actually become functional never seemed to arrive. The promise was tempting: to reproduce on Earth the same process that powers our sun, generating practically unlimited energy, and all that without carbon emissions and with minimal amounts of fuel. Now, for the first time, that future seems much closer. In July 2026, Commonwealth Fusion System published a peer-reviewed scientific validation by Paris for the ARC project. This is a commercial fusion plant capable of producing energy on an industrial scale. The study was published in the traditional Journal of Plasma Physics and represents an important milestone for the sector. At the center of the project is a tokamak-type reactor, a ring-shaped machine designed to confine plasma using extremely powerful magnetic fields. Computer models indicate that the ARC will be able to operate with magnetic fields greater than 11 Tesla and gigantic plasma currents that would produce about 1.1 gigawatts of fusion thermal energy. And after conversion to electricity, this represents approximately 400 megawatts available to supply the power grid. But producing the energy is not the biggest challenge. The real problem is controlling plasma that reaches temperatures above 150 million degrees Celsius. No known material could touch this plasma directly without being instantly destroyed. And for those of you who usually say that it's impossible to have the power of the sun here on Earth because it would destroy everything, pay attention to this explanation here. It's really simple. To solve this problem, engineers developed an advanced system that uses magnetic fields to keep the fuel suspended in the air and away from the reactor walls. In addition, small amounts of gases like neon and argon are strategically injected to create a kind of protective cushion, reducing the thermal impacts on the internal structures. If the ARC delivers in practice what it promises in calculations, we will be witnessing the beginning of a new era of energy. An era in which humanity will stop merely observing the stars and will begin to use here on Earth the same force that has kept the sun shining for billions of years. But technologies don't stop here on Earth. We know that, right? They're always going to be sent out into space. Up there. Let's take a look at this one now. We know that radars already observe the skies, ground systems already calculate trajectories, and interceptors try to destroy threats already in flight. But now a new arms race is taking this battle far beyond the atmosphere. Northrop Grumman has announced a strategic partnership with the satellite manufacturer Apex. The idea is to develop space interceptors linked to the Golden Dawn initiative. That United States project aims to turn Earth's orbit into a permanent layer of defense against ballistic missiles and hypersonic weapons. The proposal is part of a program supported by the United States Space Force. The goal is to create a network capable of identifying, tracking, and intercepting threats during flight, still in the early stages. And the test results were considered positive enough to allow progress toward the first orbital test, now scheduled for 2027. The idea is simple and ambitious at the same time: to quickly manufacture hundreds or even thousands of units capable of carrying different types of sensors and interceptors. Basically, what they're trying to do is wrap the entire Earth in a mesh of technological protection, and thus prevent us from turning our planet into a kind of Mars 2.0. And speaking of Mars, focus on this next story. It's really interesting. It has always been believed that future Martian agriculture would depend on huge amounts of resources sent from here on Earth. Now, a discovery published in 2026 suggests a much more elegant solution. Instead of transporting tons of fertile soil through space, researchers are studying how fungi from Earth could transform Mars' toxic dust into a future extraterrestrial farm. The problem starts with the Martian soil itself, known as regolith. It's far from suitable for cultivation. In addition to having a highly alkaline environment, the material contains almost none of the nutrients needed to sustain plants, and still has high concentrations of potentially toxic elements, such as aluminum and manganese. It was precisely in this scenario that scientists found an unexpected solution. Some species of the Trichoderma genus have shown the ability to metabolize toxic compounds in the regolith and, at the same time, enrich the environment with important nutrients for plant development. But the strategy goes further. Researchers are also studying mycorrhizal fungi. These are organisms capable of forming a direct partnership with plant roots. This association improves nutrient absorption and helps plants better withstand the extreme conditions of an extraterrestrial environment. The fungus Cliomycus antarcticus, found in extreme environments here on Earth, has already demonstrated the ability to survive space radiation and vacuum during experiments conducted outside the International Space Station. And if it can withstand open space, it might be among the first organisms capable of helping to turn Mars into a biologically productive environment. Maybe none of these technologies alone, my friends, will be able to take us to the stars, which is what many people want. But together they can start to form something much greater: the infrastructure of a civilization that learns to live beyond Earth. So, do you think all of this can really happen and will start now? Leave a comment below if you can. If you enjoyed this episode, like and make sure you're subscribed. Thanks for staying with me, and see you next time. Click one of the 2 suggestions on your screen, okay? I'll be waiting for you there, all right? Bye, see you soon. Click there.